All right, kicking off chapter 3 with some review on factoring, right? Prime factorization, greatest common factor, all things we need to review to be successful, right? So prime factorization is a way of expressing a number as a product of its prime factors. A prime number is a number that has exactly two factors, one and the number itself, right? So prime numbers, right? They're the ones that cannot be divided out any further. So our prime numbers have exactly two factors. So 2 can only be made with 1 times 2, 1 in itself. 3 can only be made with 1 times itself. 4 is not prime, it's composite, right? Because you can go 1 times 4 and 2 times 2, so it has 3 factors. 5, 7, 11, 13, 17, 19, 23, 29, 31. Okay, those are some examples of prime numbers. 1 is not prime because it only has one factor. It's an anomaly. It has just one factor, so it is neither prime nor composite. A lot of times people start out by doing prime factorization with a factor tree, right? What are ways that I can multiply to 30? So 3 times 10. Right? You could go 5 times 6 as well. 3 is one of my prime numbers, right? So I'm going to mark that as done. And then 10 is not a prime. It can be made by multiplying 2 by 5, right? And both of those are prime. So the prime factorization of 30 is 2 times 3 times 5. So for 48, different ways we could start this. First one that pops into my head is 6 times 8 is 48. Those are both composite, right? So 2 times 3, those are both primes. 8 can be made by 2 times 4. 2 is prime, but 4 is not, right? So 2 times 2 for 4. So my primes are 2 times 2 times 2 times 2 times 3, right? So my prime factorization for 48, some people would write out all the 2's. You could say 2 to the 4th power times 3. That would also work. Right, so that's just a quick review of prime factorization. Now that we've done that, we have greatest common factor. Right, so the first thing that you need to do, greatest common factor, is the set of numbers, of a set of numbers is the largest factor that all the numbers share. Right, so here is my prime factorization for 30 and 48. Right, 30 has a prime factorization of, it was 2 times 3 times 5, right? 48 had a prime factorization of 2 times 2 times 2 times 2 times 3. Right, that was my prime factorization for those. What I am looking for now is numbers in both lists, right? They both have a 2 and they both have a 3, right? So their prime factorization then would, or their greatest common factor is 2 times 3, which is equal to 6. For 20 and 55, right, we need to do our prime factorization. 5 times 11 for 55. Right, so 55 is equal to 5 times 11. 40 is 4, or 20, sorry, is 4 times 5, which would be 2 times 2. 2 times 2 times 5. And the greatest number in both lists there would just be the 5, right? So that has a greatest common factor of 5. Factoring using greatest common factor To factor using a GCF, take the greatest common factor for the numerical coefficient. When choosing the greatest common factor for the variables, if all the terms have a common variable, take the ones with the lowest exponent. So let's see here. We have 2a plus 2b, right? So our greatest common factor of the coefficients, right? Coefficients are the numbers out in front, right? So they both have a 2, right? They both have a 2. So the greatest common factor of the coefficients is 2. Now, looking at the variables, the x, y's, a's, b's, right? I have a and b. They do not have any common variables, right? So there is none here. Now we just divide. So we say that the greatest common factor here is 2. Now we're just going to divide each of those terms, each of those monomials, by the greatest common factor, right? So 2a plus 2b is equal to, right? I can divide out a 2 and get a plus b, right? So that is factoring using greatest common factor. Let's look at some more examples here, right? Looking at the coefficients, I have 9, 3, and 12. 9, 3, and 12, right? And so I know these are all divisible by 3. So that has to be my greatest common factor for the coefficients because that's all that the 3 is going to have. Looking at my variables, I have x to the 4th, I have x to the 3rd, and I have x squared. Okay? I am going to take the smallest exponent. I'm going to take this x squared. So the greatest common factor here is 3x squared. So to find the greatest common, to divide out the greatest common factor, we're going to factor out that 3x squared. So I have 9x to the 4th plus 3x to the 3rd plus 12x squared. I am going to divide out that 3x squared from each term. Right? So, looking here at 9x to the 4th, if I divide out 3x squared, 9 divided by 3 is 3, and then x to the 4th divided by x squared would just give me x squared. 3x to the 3rd divided by x squared, right? I'm going a term at a time. Now I'm here. 3 divided by 3 is 1, and x to the 3rd divided by x squared is just x, right? 3x to the 3rd divided by 3x squared. The 3's cancel, right? X to the 3rd divided by x squared is just x. And then finally, 12x squared divided by 3x squared. Well, 12 divided by 3 is 4, and x squared divided by x squared, those are going to cancel out. Right, so that brings us to the end of the review. You now have some assignment to complete, so go ahead and get that done and submit it.